Hey guys, what's up? Welcome back to the classroom. It's Mr. Low. Going to move on to the new chapter, chapter 11, titled Triangles, Quadrilaterals, and Polygons. Alright, this video lecture is broken up into three different parts. Namely, we are going to touch on, in this first video, the triangles. Okay, we're going to learn about the angles concerning the shape triangles, right? And in the second video, we're going to talk about quadrilaterals. Quadrilaterals essentially are four-sided figures. Right? And lastly, in the third part, we are going to discuss on polygons. Polygons essentially are shapes. They are made out of a few sides. They are straight lines. So the number of sides can be greater or equals to 3. So that means, for example, triangles are an example of polygons. Quadrilaterals are examples of polygons as well. Then you do know that we have things like 5-sided figures, 6-sided figures, so on and so forth. Right? Okay, so without further ado, let's move on. But before we do that, let us do a recap on the knowledge that we have from the previous topic on geometry. Right? We have learned some angle properties that will be very useful in this topic. So let's do a quick recap. So for instance, we have a straight line here, and I have a line that cuts through. Okay, it doesn't cut through, but that touches the horizontal line. And we do know that, right, angle A plus angle B. I should write an angle over here, pardon me. Okay, so for instance, angle A plus angle B gives me 180 degrees, correct? Okay, so the reason for this is angles on a straight line. On a straight line. So there's a lot of things to write, but don't forget your reasons, right? So what else? What else have we learned? We have learned things like for a pair of parallel lines, okay, and a transversal that cuts through the pair of parallel lines, we have this too, right? C and D, right? Angle C equals to angle D, and what's the reason here? Alternate angles, right? If you recall. What else? What else do we have? We have, for instance, let's call this angle E now. Okay, now we have angle C plus angle E equals to 180 degrees. And what's the reason here? Interior angles, right? INT angles. Okay, so on and so forth. We also have corresponding angles. For example, angle this one, angle F equals to angle G, right? So we know that there is corresponding angle, so on and so forth. Right, so we'll be needing some of this knowledge that we have from the previous chapter in this topic. Okay, let's move into what we're going to learn for this video. In this video, we're going to learn to identify different types of triangles, right? Not all triangles are made equal, of course. Okay, state the properties of different types of triangles. Okay, we're going to focus on the angles concerning triangles. We are not too concerned about the area, the perimeter, so on and so forth. Okay, and last but not least, we are going to solve some problems involving these properties. Alright, so good. Let's move on. Okay, so first type, we're going to classify different types of triangles since they're not all made equal. Okay, so for first type, let's take a look at this. This type of triangle, by definition, has 3 acute angles. We all know that triangles have 3 different sides. 3 sides. Some may be equal, some may not, and of course, because of that, we have 3 angles inside the triangle. So, if all the angles here are acute, recall, what does acute mean? It means that it is lesser. That means these angles are lesser than 90 degrees, right? Acute angles, right? You do not include the 90 degrees, right? Because 90-degree angles are called right angles. So what do you call this type of triangles? We call them acute triangles. Right, as the name suggests, acute triangles. Okay, let's move on. Next one, a triangle with very special 1 right angle. Okay, so here we have it over here. We have 1 right angle over here. So what do we call this? Well, of course, I think most of you know. We call it the right angle triangles. Okay, right angle triangles. Right, any triangle with 1 right angle, they're right angle triangles. Next one, a triangle with one obtuse angle that we have it over here, and you can guess it very quickly, is called an obtuse triangle. Alright, so we have essentially, when it comes to angles, you know, the size of the angles in the triangle, we have these three types: acute, triangle, and obtuse. Let's move on. Alright, so we have some angle properties, okay, with regards to triangle. Okay, by the number of equal sides a triangle has, this will affect the angles inside a triangle. But before that, we might recall that, right, angles from primary school, maybe we have learned this in primary school, that the sum of the angles inside a triangle, all the three sides add up together, should be equals to 180 degrees, right? So let's recall. Sum of angles in a triangle gives me 180 degrees. Pardon my handwriting. Alright, I don't care what type of triangle it is, right? I don't care is it an acute, an obtuse, or a right angle triangle. Right, all the three angles add up to 180. Okay, so we have a few types now that concerns the angles. Let's look at the first one. By definition, this triangle has three equal sides. Okay, so you can see that in this triangle here, AB equals to AC equals to BC. And maybe not so surprised to you, all the three angles are the same. Alright, so all the three angles in an equilateral triangle. So this type of triangles, we call it equilateral triangle. They are equals to 60 degrees. And you do know why. Why is it that they are all equals to 60 degrees? Because they are all the same size. So if let's say I call it angle ABC, which is this guy over here, plus angle BCA, which is this guy here, plus angle CAB, which is this guy over here, is equals to 180 degrees. Since they are all the same, no choice, either of this angle, let's just choose ABC to represent it, is 180 over 3, since they're all the same, right? 180 degrees, so you have 60 degrees over here. Each of them must be 60, since they're all the same, right? So we call this type of triangle the equilateral. Okay, you can sort of figure that there's the word equal over inside this word, equilateral triangle. So that's how I remember this. So the abbreviation, the shorthand for this, please check with your teacher how he or she wants you to exactly write this. But the way I'll write this is EQ triangle. Okay, do not follow strictly. Please check with your teacher how he or she wants to do it. Okay. Next, we have a less special case. This time we only have a pair of equal length. So AB equals to AC, but not equals to BC. So in this case, because of the two lengths are the same, these two angles here, angle ABC and angle BCA, they are equal. So you have a triangle with at least, check the word here, at least two equal sides. Okay, so what do you call this type of triangles? If you can recall, maybe you have learned this in primary school. Okay, it's called the isosceles triangle. Now, please check here. The definition here says at least two equal sides. So does it include three equal sides? My question to you is, does it include triangles with three equal sides? Yes, of course, because 3 is at least 2 or 3. So I can say that an equilateral triangle is a special case of an isosceles triangle. But usually when we refer to isosceles triangle, we refer to this type, 2 equal sides. If we have 3 equal sides, we will call it a equilateral triangle. So please don't get confused. Okay, the base angles of an isosceles triangle are equal, as we've highlighted just now, and the abbreviation here is isosceles triangle. ISOS, so it's like a short form, but please again check with your teacher how he or she wants you to write it properly. Okay, moving on. Now you have a less special case, of course, a triangle with no equal sides. Yeah, so all these three sides here, the blue, the red, and the black, they are all not the same line. None of them are equal. So what do you call this type of triangle? We call it the scalene. S-C-A-L-E-N-E, scalene triangle. Alright, so all the angles in the scalene triangles are different, of course, because none of the sides are equal. But one thing in common here is still applicable for all the three types of triangle is this. The sum of the angles inside the triangles, they are all add up to 180 degrees. I don't care which type. Okay, so just now as we said, discuss here, an equilateral triangle is a special type of isosceles triangle, okay, because of the word at least two. Moving on. Okay, so let's recap here. Yeah, so we have discussed just now, okay, the sum of triangles, the sum of angles in a triangle is 180 degrees. So you use this to quote for your reason, right? Okay, sum of angle sum of triangle. Sure. Moving on. Okay, now whatever we said just now, this angle, okay, the sum of angles in a triangle, namely angle ABC, they are actually called interior angle. Let's take a look at this. Interior angle. Why are they called interior angles? I-N-T-E-R-I-O-R. Interior angles, right? All these guys are interior angles. Why? Well, if you can see that is inside the triangle, right? So if you've heard of the word interior design for houses, you would know that interior designers take care of the design of your house on the inside, not on the outside, right? So it's interior. Okay, now as opposed to the interior angles, we have exterior angles. Exterior are opposite, outside the triangle. Okay, so let's look at the line here. The exterior angle of a triangle is equal to the sum of interior opposite angles. Let's highlight this word opposite angles. Okay, and the abbreviation here is this exterior angles of a triangle. Now what does it mean? There's a lot of words here, there's a lot of things to learn here. So let's use this triangle as an example here. Okay, what you have here is a triangle ABC, and then a horizontal line is extended, you know, from BC, right, and it extends to D. So we have BCD as a straight line, right? Now then we mark out this angle here. Now when we say that this angle is the exterior angle, is one of the exterior angles of the triangle, okay, because it's outside. So are we able to mark down more exterior angles? Yes, we can. We simply need to extend the other two sides. Let's say I extend AC over here. Let's call this point E. We have another exterior angle here. Okay, so this is another exterior angle. Any more? Is there any more that we can find? Yeah, why not, right? Let's extend AB. And then this angle here is also another exterior angle. Alright, so you can see that for a triangle, there are three exterior angles. Okay, because simply this triangle has only three sides. Later on, as we move on to shapes with more sides, you will see that, you know, there are more exterior angles to discuss. Okay, moving on, or maybe I should label this part F so it's later easier to discuss. Okay, so this is point B over here. Okay, so let's see, what does this line say when it says that the exterior angle of a triangle is equal to the sum of the opposite interior angles? Let's take a look. Let's say I'm looking at angle X over here. Now this is an exterior angle, clearly. Okay, now the interior angles that are opposite, right, opposite to this X are namely angle A and angle B. So how do I figure this out? Okay, let's look at from angle X. Usually I'll do this. I'll draw an arrow like this, two arrows like this to the opposite sides. Alright, so from here I do know that A and B are angles, their interior angles opposite to the angle x. So from here, is there anything written in the notes? Yeah, so from here we do know that in this particular example here, angle x equals to angle A plus angle B. Okay, and we don't need to quote the reason here, which is exterior angle of a triangle. BXT, angle of a triangle. Okay, now can we do so for angle Y? We do notice that in this diagram there is another exterior angle, which is angle Y. Let me use blue color instead, okay, this time. So can you pause the video for a while to write down the equation that concerns angle Y using the property exterior angles of a triangle? Let's pause the video to do it. Alright, are you done? Okay, first of all, we have to figure out what are the two opposite angles to angle Y. Opposite interior angles, I should say. Right, if you figure out this, there are B and C, then you're absolutely right. So you have angle Y equals to angle B plus angle C. And the reason is the same, exterior angle of a triangle. And we are done. Okay, so this is one property that of triangles that we need to learn. So actually this is the second one. First one is the sum of interior angles. And a triangle is 180 degrees, then you have exterior angle equal to the sum of opposite interior angles. Moving on. Okay, so we will do a practice question now. So let's study the diagram first. I always like to study the diagram first before I even go ahead and read the questions. Okay, so let's see. I have a triangle here, ABC, and it's very clearly stated in the question that I have two equal sides. So what type of triangle is triangle ABC? If you tell me isosceles triangle, you're absolutely right. Now, once we've identified that triangle ABC is isosceles, we can deal with the angles inside the triangle. Which two angles are the same because triangle ABC is isosceles? Aha! So if you manage to tell me that this angle equals to this angle, namely ACB equals to ABC, then you're right. So immediately I can know that angle ABC is also equals to 3x degrees. Am I right to say that? Okay, and we can also figure out that we can actually write down by the side, by the first property of triangles that we learned, sum of interior angles in a triangle equals to 180 degrees. We have angle Y, or more like Y degree plus the other two angles that are equal, gives me 180 degrees. Maybe I can simplify this expression, this equation. Y degree plus x degree, is equal to 180 degree. So that's the first piece of information that we can gather from the diagram itself, right? Now I also spot an exterior angle over here, right? And it's labeled as 9x degree. So based on the second property, so this is the first property, based on the first property, based on the second property that we've learned, what can we do with this 9x degree? Well, we're going to use the property exterior angles equals to sum of opposite interior angles. We know that from this diagram, 9x degree equals to, what are the two opposite? These two fellas, y degree plus 3x degree. Okay, so let me rearrange the equation a bit. So I have 6x degree equals to y degree. Alright, so these are the two pieces of information I can immediately get without looking at the question, by simply examining the diagram itself. Alright, with this information, let's dive into the question. Given that AB equals to AC, yeah, we already know that. Okay, and ACT is 9x degree, we already know that. Okay, so these are all the angles. Stating the reasons clearly, please don't forget to give your reasons. Alright, we deduct marks if you don't give. Calculate the value of x and y. Okay, so we have already done half the work essentially by looking at the diagram. So let's begin with part A. Okay, we're interested in finding angle x. Okay, so what do we have over here? We have these two pieces of information. 6x degree equals to y degree plus 6x degree equals to 180 degrees. Okay, so let's rewrite them down. I know it's we have already done it, but let's do it in the question properly. Okay, so we have y degree plus 3x degree. Oh no, but before that, we need to tell the examiner that we know that angle ABC is equals to 3x degree. Why? How do we know that? Just now we used the property of isosceles triangle, right? Because we spotted an isosceles triangle. Okay, next. From there we have, right, sum of interior angles in a triangle, y degree plus the two equal angle equals to 180 degrees. So from there we know that we should have already done it. Y degree plus 6x degree equals to 180 degree. Alright, so you realize that it's a bit difficult for us because here we have two unknowns in the same equation. Now, as a rule of thumb, if I have two unknowns, I need two different equations concerning these two unknowns in order for me to solve for their values. So we need two equations here. We have one equation here. Which one is the other second equation? Actually, we have it already over here. This is my second piece of information. Alright, so I'm going to utilize my second piece of information here. Okay, so this is exterior angles. So we have 9x degree equals to y degree plus 3x degree. And what's the reason here? Exterior angle of a triangle. Okay, so I give the reason here immediately. From there, I reshuffle the equation. I have y degree equals to 6x degree. So this is my second piece of information. Now, how am I going to make use of combine these two pieces of information? Well, you realize something here. I have y here, I have y here. Do you notice that? I have y here, I can have y here. Can I simply replace the y over here? Why not, right? So let's try. Okay, I'm running out of space, so I'm going to do it over here. So replacing my angle y with 6x degree. So I'm going to refer to my equation number 1, like my first piece of information. From 1, okay, y degree plus 6x degree equals to 180 degree. That's my first piece of information. I'm going to replace my angle y with 6x degree. 6x degree plus 6x degree equals to 180 degree. So from here, everything comes naturally. This is your very basic algebra, yeah? Okay, I'm gonna leave it to the simplest form first. I'm not gonna leave it in decimal. So how do I simplify this? 60 over 4 degree. So I'm dividing both sides by 3. I'm gonna divide both sides by 4. And that gives me 15 degrees. Sorry, it's an exact number. Okay, I thought it's going to be a fraction, but it's a nice number, 15 degrees. Okay, so immediately I have found x. Angle x is 15 degrees. So we're done for part A. Part B, how am I going to find angle y? Let's go back to information number 2. We have x now. Now we have found x. Can we go ahead and find y? Yes, we can. So I'm going to quote my equation 2 from equation 2. Okay, y equals to y degree equals to 6x degree. And I'm just going to substitute x equals to 15 into it. 6 times 15 degrees. That gives me, oh, it's a right angle. Interesting. So turns out, this angle y here happens to be a right angle triangle. Interesting. Sorry, my angle y is a right angle, right? And this triangle here is a right angle triangle. Alright, I hope this is clear. Moving on. Here again, we realize that we have two different unknowns, y and x, right? X and y. Okay, so again, probably we may need two different pieces of information that we can obtain from this diagram. So let's look at the diagram first before we do anything. Okay, immediately I spot that there is a right angle here. And there's a 24 degrees here. Can we go ahead and find this angle? Why not, right? This angle over here is nothing but 180 degree minus 90 degrees minus 24 degrees, and that gives me 66 degree. Okay, so because of interior angles in a triangle, sum of angles in a triangle, I should say. So I'm going to immediately erase this and replace my information that I just obtained. This is 66 degree, but I must remember to do it properly later. Alright, so what else do we have? Okay, I see that there is a exterior angle here, right? This exterior angle, which two angles are the opposite interior angles to this? So we know that we have this angle over here is one of them, and this 24 degrees. So I know that I can immediately find my angle X. Okay, then after finding angle X, what's my strategy for finding angle Y? I see that there's a straight line here. And the three angles here add up to 180 degrees. So I can find my Y. So I already have a strategy to find. So let's do it properly. Okay, so I realized that there is no labeling of points in this diagram, right? There's no letters. Unlike this, there's no ABCD over here. Okay, can we go ahead and start adding in points on our own? Okay, but before I do that, I need to remind you again that if you are going to add additional pieces of information on your own in a diagram, okay, if your answer, the answer booklet is the same as your question booklet, that means you are going to write your answer in the question booklet, no problem. Okay, you can just go ahead and add. But if the test paper requires you to write your answer in a foolscap paper that is separate from the question paper, you need to redraw the diagram, okay, so that you can add extra pieces of information. If not, when the examiner looks at your foolscap paper, he or she will not know what you're talking about because there's no diagram over there. Alright, so I'm going to start labeling the important points here. Okay, so for example, a triangle ABC, then I probably need this one, D also. I probably need this one for an exterior angle. I need this one over here because I need the straight line, the green color straight line. Probably that's it. Okay, in case we need more, then we're just gonna go ahead and label more later. Okay, so the first step that I did just now was to identify that this is 66 degree. Right, so let's go ahead and redo what we've done just now, this time with the letters. Okay, so we have angle DBC equals to 180 degrees minus 24 degrees minus our right angle, and that gives me 66 degrees. And what's the reason here? The reason here is sum of angles in a triangle, right? In a triangle. Okay, so now I've identified my 66 degree. How am I going to find angle X? Well, our strategy just now was to make use of this exterior angle. Okay, so I'm going to make use of this exterior angle here. So I'm just going to go ahead and write 132 degrees equals to, okay, so this angle over here is made out of X and 66, right? So I'm going to add them up. X degree plus 66 degree plus, what's the other opposite angle? This guy here, 24 degrees. Okay, and the reason here is exterior angle of a triangle. So far so good. So immediately I'm able to find my X. Okay, I'm running out of space, so I'm writing everything in one straight line. Please do not copy. Okay, so 66 plus 24 is 90 degrees. 132 minus 90, that gives me 42 degrees. So I have my angle X as 42 degrees. Immediately I'm done with angle X. Right, next is angle Y. Okay, And the strategy that we say we're gonna use here is to use the green color straight line, right? Sum of angles on a straight line. So without further ado, let's just get into it. Y degree plus x degree plus 66 degree equals to 180 degrees. And before we forget, let's quote the reason. Sum of angles on a straight line. Oh my god, there's a lot of things to write. Alright, so without, okay, the next thing we know is x is 42 degrees. So let me replace it over here. Y degree plus 42 plus 66 gives me 180 degrees. Gosh, I'm running out of space, pardon me. Ignore this, can write below. So immediately we can find y is 180 minus 42 minus 66. And can you help me with the calculation here? 180 minus 108, that is 72 degrees. Alright, so that's it. Very simply, we have already found our x and y. So we have made use of exterior angle property. We have made use of sum of interior angles in a triangle. We have made use of sum of angles on the straight line. That is the previous chapter. So please do not forget your stuff. Moving on. How many examples we have? We have 2 more examples. Alright, so bear with me. This is the second last example. Okay, calculate the values of the unknown in each of the following diagrams, and of course, not forgetting to state your reasons. Right, so where are my unknowns? I have A here, I have B here. Okay, so let's take a look. Before we go in, let's take a look at what we can obtain from this diagram itself. Okay, I see that there are 2 straight lines here. Okay, so once I'm able to form a cross and X, what can I do? If you're sharp, you can immediately tell me this is vertically opposite angles. Okay, so once you have vertically opposite angles, you realize that angle A is inside this triangle. And we have 2 of the angles already. So we have already found our A. Okay, so this is our strategy to find A. How about angle B? For angle B, you realize that this is an exterior angle to which triangle? This one over here. Okay, I'm going to use green color. So these 2 are my opposite interior angles. Actually, we're done. We realize that we are done. We have found the strategy to find A and B. The next thing is just to write it down nicely. But before I do that, again, I realize that there is no labeling in this triangle. So I'm just going to in this diagram, I'm going to go ahead and put in some points. A, B, C, D, E, F. Right? So we will use this system of letters to label our angles. Okay, so let's go ahead and do it. The first thing that we did was to identify the vertically opposite angle. Alright, so we have angle BAC equals to angle DAE. Equals to 67 degrees. And what was the reason? Pardon me. And the reason here was vertically opposite angles. Okay, next we are going to deploy the blue color triangle over here and triangle ABC to find our angle A. Right, so A degree plus 36 degrees plus our 67 degrees, that gives us 180 degrees, and the reason here is sum of angles in a triangle. Okay, so very quickly we can find angle A. Minus 36 minus 37, sorry, 67. So this is 36 plus 67 is 103. So 180 minus 103 is 77 degrees. So our angle A here is 77 degrees. And we are done with angle A. Next, for angle B, we're gonna use the property exterior angle, right? So B degrees equals to the 2 opposite angles sum up, 67 degrees plus 42 degrees. And the reason here, let's quote before we forget, okay? Exterior angle of a triangle. So what's the answer here? This is 109 degrees. Done. So easy. Okay, we have found A and B. Right, moving on to the last example over here. Okay, so let's see. Let's go straight into the diagram first. I have two equal sides here, and because of that, we know that this is 80 degrees. Simply, right? And because these two are 80 degrees, we can use triangle ABC to know that this is 20 degrees. Right, if your mental sum is fast, you will know. Okay, now next. Well, I also know that this is equals to 20. See, I'm moving very fast. Why? Because vertically opposite angles, right? Okay, and then since this is 120, this is 20, I'm going to use triangle BED to tell me that this angle here is 40 degrees, right? Because they all add up to 180. Okay, now next thing I also know is that since this is 120 and we have a straight line DEF, I know that this angle is 60 degrees, right? Because angles on the straight line. Then how am I supposed to find this angle over here? Can you see that we have a triangle AEF? Right, so we can make use of this triangle. We already know two of the angles, right? So we know that this very quickly, sum of angles in triangle, this is 40 degrees. Okay, if I'm moving too fast, just pause and try it on your own. Try thinking through the process on your own and check with my answers. Okay, so basically we have just used three properties over here. Okay, we have isosceles triangle. We have used vertically opposite angles over here. We have used sum of angles, interior angles in a triangle. Okay, so turns out we have most of the angles already. What else can I find? I can find this because of triangles DC and F. Okay, so we have this 40 degrees, we have this 40 degrees. So turns out this is 100 degrees. Alright, we have most of the things that we need already. So let's go ahead and look at the question. Okay, so given the two angles here, find the following angles, and of course stating our reasons clearly. Don't forget that we have to find angle BDE. Where is BDE? BDE. This angle here, right? This black color angle here, which I've already found. Okay, of course there are many other methods you can use to find this angle, right? Mine is just one of them. Please feel free to share your method with the class as the teacher goes through this, right? I challenge you to use more other methods to find this. So we are tasked to find this one. We're interested in this one, and AFD. Where is AFD? AFD. We're interested in this one. Actually, we have both the answers. Okay, so let's think about how we did this. Okay, so to get to angle BDE, we started off from triangle ABC. Okay, so let's label our let's do our workings properly. Okay, I feel that there are many steps here. Okay, so let's start off with this, right? We started off with this 80 degrees here. We know that angle ACB equals to angle CAB equals to 80 degrees because we have a isosceles triangle. Next, we can go ahead and find angle ABC is 180 degrees minus our 280 degrees. That gives us 20 degrees. Sorry. That gives us 20 degrees because of sum of angles in a triangle. Okay, so now once we have this 20 degree over here, we can proceed to push it to this 20 degrees. So angle DBE, next angle DBE is also equals to 20 degrees. Why? Because of vertically opposite angle, right? So now after we have found this one, we're gonna make use of triangle DBE. to find our first unknown angle. Okay, so we have angle BDE plus our 20 degrees that we just found, plus the given 120 degrees. They sum out to 180 because of the sum of angles in a triangle. Pardon my handwriting. Okay, sum of angles in a triangle. So we know very quickly angle BDE is 40 degrees. Yeah, 40 degrees. Okay, so we are done with the first part. So that is part A. I forgot to label my working. Okay, now part B, we are interested in the next one. This guy here, right? This guy over here. So how do we do it? In fact, I spotted a shorter method. Okay, if you forgot what I did just now, just rewind the video and go through my whole thought process. But I spotted a faster method. I'm not so sure if how many of you managed to. Can you pause the video and find a shorter method? Okay, do you manage to find it? The clue is this angle here, 120 degrees. What can I say about this 120 degrees? And in fact, if you're sharp enough, you realize that this is the exterior angle of triangle AEF. Alright, so pardon me, I'm gonna erase everything so it's not so messy. Okay, so that you can see very clearly. Yeah. Okay. If you need the annotation, just rewind the video. So you realize that this angle, 120 degrees here, is the exterior angle of triangle AEF. And these are my two opposite interior angles, right? So just now we have found we have found AFE to be 40 degrees. Okay, 40 degrees. No, sorry, we need this is our task. Our task is to find this, right? Okay, so we already know 120, we know 80, so we can go ahead and calculate. Okay, so 120 degrees plus 80 degrees plus angle AFE. Sorry, 120 degrees equals to 80 degrees plus angle AFE. A bit of mind block there. Okay, and the reason here is exterior angle of a triangle. Alright, so from there we can quickly find AFE equals to 120 minus 80. That gives us 40 degrees. And we're done. Okay, we have found our two angles that we are told to find. Sorry. So that's it for this part. Alright, so let's do a quick recap here. We are utilizing two properties that we just learned, or maybe you might have learned this before. Sum of interior angles in a triangle. Here I'm using the word interior because we've already learned what is exterior, what is interior. Okay, the three angles sum out to 180 degrees. I do not care what type of triangle it is. So long as it's a triangle, this applies. We also learned that the exterior angle of a triangle is a sum of its two opposite interior angles. And as of course the abbreviation, please remember to quote the reason, right? Again, this applies to any triangle. I don't care what type of triangle it is, right? We have used these two properties to try to solve, to find some weird angles inside some examples, right? Not forgetting to label all the points that you need to label your working, right? Many of you, the problem is with your work is that you do not label your workings properly. You do not label your angles properly. You just slap down a few equations, a plus b equals to c, something divided by something, something times something, without telling the examiners what exactly you're finding. So because of that, you are likely to lose a lot of marks because the examiner does not understand what you're trying to do over here. So please remember to, number one, label your working. Number two, to quote all these reasons that you are tasked to quote. Because if you do not state your reasons clearly as instructed, this means that you don't know how to read the question marks will be deducted off, of course. Right, so that's it for this video. In the next video, we are going to move on to four-sided figures, quadrilaterals, and we will see how angles in the properties of the angles inside quadrilaterals. Alright, looking forward to seeing you in the next video. Take care.